Hi everyone, in this video we'll explore when math is useful in forensics. At around 8 p.m., Adam came home and found that his roommate is dead on the floor. He immediately called the police, and a few minutes later, a coroner, Alex, showed up at the scene to do some investigations about the dead body. At 8:20 p.m., she took the body's temperature and got 92 Fahrenheit degrees. At around an hour later, or 60 minutes later, she took the temperature again and got 90.2 Fahrenheit degrees. A few minutes later, the detective Jed showed up, walks around, and he noticed that the thermostat in the room indicating the room temperatures is about 72 degrees. He asked Alex, "Can we figure out the time of death?" Alex is like, "Yeah, sure. We can use math to do that." Alex explains the process of using mathematics in order to figure out the time of death for this victim. First, she introduces the function big T of small t, where big T is the temperature of the dead body in Fahrenheit degrees, and small t is time in minutes. She also used the notation big T of A for the room temperature in Fahrenheit degrees. Remember the first time that she checked the temperature? She got 92 degrees, so she assigned this time to be 0. So small t equals to 0 for this point, and she gets a data point, which is big T of 0 equals to 92. And the second time when she checked the temperature, she got 90.2 degrees, which is 60 minutes later. So she assigns small t to be 60 for this point, and she gets another data point, which is big T of 60 equals to 90.2. And the room temperature, big T of A equals to 72, which is a constant. So using the Newton's law of cooling, she found a function for the temperature of the body in terms of minutes, where T of 0 is the temperature at the first checking point, and T of A is the room temperature. Plugging all the information in, she gets a more informative information for the temperature of the body, which is equals to 20 times e to the negative kt plus 72, where 72 is the room temperature. As you can see that we have an unknown constant k in these functions, and the reason why it's unknown is because for these types of problem, the constant k would be different for different types of bodies. So for different people, the temperature of the dead body would have different constant k. So Alex uses the second data point in order to figure out this constant k, where she plugs 60 into the time, 90.2 into the temperature to get another equation. And this equation only has one unknown variable, k, which can be solved. Using the previous equations, she moved 72 to the other side, divided both sides by 20, and since k, the unknown variable, is a part of the exponent, she applied natural log to both sides. This reminds us that there's a logarithm properties which saying that natural log of a to the x equals to x times natural log of a. So applying these properties into this equation, she moved the negative k times 60 down in front of natural log of e, and natural log of e equals to 1, so she can solve for k by dividing both sides by negative 60. She calculates the k is approximately to be 0.00157. So back to the problem, remember that she found a function for the body temperature, in terms of K and T, and then she found a value for K. So then she would get a complete functions for the body temperature in terms of minutes. So the question now is, how can she figure out the time of death? So she assumes that when the victims died, his body temperature is about the average human temperature, which is about 98.6 Fahrenheit degrees. So if we can figure out the time that is associated with this temperature, then that would be the time of death. Plugging in 98.6 into the temperature, we have an equations in terms of T-death, which is the time of death, which is an unknown variable in these equations. So we can solve for the time of death using this equation here. Alex manipulates some of the algebra skills, taking the natural log of both sides to figure out the time of death, T-death, is about negative 181.64 minutes. And wait a minute, can time be a negative value? Does it make sense? Usually, time should be a positive value, but in this case, in this example particularly, because Alex assigns the time of the first checking point to be 0, so the time of death has to be some hours and minutes before t equals 0, which means the time of death should be equals to a negative value. And she converts this minutes into hours and minutes, which is about 3 hours and 1 minute. In order to help us visualize the timeline of this problem, she provides a graph of a function of the temperature, where you can see that the red curve is the graph of the temperature of the dead body. T0 here is a temperature at the first checking point. T60 is a temperature at the second checking point. And the time of death is about 3 hours and 1 minute prior the first checking point, which is 5:19 p.m. Alex is like, see, math is everywhere. And she also has a question for you. So using the temperature at the first checking point, we call it T0, and temperature of the second checking point, we call it T sub I, where I is the amount of time after the first checking point, and the T ambient, which is the room temperature, we call it T sub A, and the human average temperature, T sub H, equals to 98.6. Can you find or come up with two formulas to find the constant K first, and then the time of death for each of the victim? Using this formula, the temperature of the dead body formula. I hope you enjoyed this video and hope you learned something new today.